Okay, welcome everybody. This is week seven of the online statistics class, and hopefully it's going well. We're now on, I would like to say, the second half of the class because it's a 12-week class. So let me tell you the plan today of all the things we're going to be doing. As always, I'm always happy to answer any questions you might have. And then we're going to get into something really important, pretty much the entire second half of the class, we're going to be doing this. So it's really important you understand what's going on today because it keeps going for good. And that is, we're going to be looking at a hypothesis testing. When you were in middle school, you learned it as a different words, you called it the scientific method. But we're going to be doing what's called hypothesis testing, which is kind of the statistics way of thinking about the scientific method. So I'm going to talk about the steps and what you're going to have to do to apply hypothesis testing. And the first is to come up with the null and alternative hypotheses. I don't expect you to necessarily know what these mean now, but hopefully by the end of the week you will. Then we'll talk about what is a type 1 error and what is a type 2 error. Okay, then after that, we'll get into what's called the level of significance. And then we'll get into the p-value. Okay, again, these are just words for you, but hopefully by, not too long from now, you'll understand them. We'll learn how to state the conclusion of the hypothesis test. We'll learn how to interpret the p-value. We'll interpret the level of significance. And I want to let you know there's going to be a lot of words in this. Okay, and I'm going to tell you certain words that have to be in, your wording, or you lose a lot of points. And I noticed a lot of you still lost a lot of points. For example, with confidence intervals, if you didn't have the word with, that means you weren't paying attention to the webinar. Um, and a lot of you didn't. Okay, so that's just a note that I'm going to mention words that need to happen, and they have to be in that. Even if ChatGPT doesn't tell you to put it in that, you have to have those words. And I'm very loud about it. I always point them out in the webinars. I yell, scream, but you have to pay attention. That's all. Okay, I always point them out. Okay, but again, if you're not paying attention, it won't matter if I point them out. Okay, and then we'll talk just the basics of Project 2. We're not quite ready for Project 2 yet. Project 2, it turns out, is on Chapter 10, and we're on Chapter 9 right now. But we can start thinking about Project 2. You just can't do details yet. So I'll talk about it. So are there any questions about anything? I spent most of the day grading today. And again, some of you had wording wrong, some of you did right. Um, it's, really important to get everything, down. But you can look at my comments. Any questions about anything? Okay. Okay. If there's no questions, I want to get into what's the big thing going on this week? What's the big thing this week? Not in this class.
He came all looking like he just played basketball. And I kept telling him to stop. He said, "Man, I don't care." And
Huh?
I said I was gonna tell Dad, and then he said, "Man, I don't care. I can't play sports anyways."
Huh? This isn't about sports.
Gotta yell at him.
So yeah, Halloween. Halloween is a big thing this week. So I thought I'd do a Halloween question. I went in and I looked for surveys and looked for something to talk about. That's what I love about this class. Unlike some other math classes, this class, I can always find something relevant to whatever's going on. So here's the question. Do the majority of adult Americans want their own Halloween night? Okay. So, you know, or do we have to do a family thing? But maybe we want our own night. So there was a survey done. Okay. And it was published by Yahoo and done by Austin American Statesman, I guess is what it said. And 54% of the 1,000 adults surveyed by Dynata said they do want their own Halloween night. Okay. So how do we find out if the majority can we know for sure that the majority of all adult Americans want their own Halloween night? We ever find that out for sure? What do you think? Yeah, the answer is no, because you can't ask every adult American, right? It'd take forever. There's hundreds of thousands. I mean, hundreds of millions. Okay, it's like a couple 100 million adult Americans, and there's no way you can survey them all. So you can't decide, you can't say, hey, yeah, I know for sure that the majority of all adult Americans want their own Halloween night. But what you can do is you can say, yeah, I'm pretty sure, right? I'm pretty sure that the majority want their own Halloween night. Not 100% sure, but I'm sure enough to, kind of stake my reputation on it. Does that make sense? Okay, so this is going to be a step-by-step process, and it's very important you understand these steps. And as I mentioned, listen to this webinar. I'm going to tell you things you have to have in the steps. And if you miss any of them, you're going to lose points. Okay. So the first step you have to do is you have to think about what is it you're trying to show, and you're supposed to write what you're trying to show and kind of like to think of it as a debate, the other side in symbols. And usually write the other side, or everyone writes the other side first. So let me show you what we're going to write. The first thing, this is called hypothesis testing. Hopefully you all know the first letter of the word hypothesis, which is not a trick question. This should be easy. What's the first letter of the word hypothesis? Yeah, H. And we're going to be using always capital H. Okay, the first letter is capital H. So this capital H right here stands for the word hypothesis. Okay, this is what everybody writes. And then there's a subscript. Okay, and that's subscript with a zero. You'll usually hear it instead of zero, you'll usually hear H naught. Anyone know why everyone says not instead of zero? See if anyone's from that culture. Okay. You may not know. Okay. The reason is because that's how they say it in British. And the British got to it before the Americans did. That's how they say the number zero. They use a not. Okay. So you'll hear me say that a lot is H not because that's how everyone says it. So you have to have these symbols, H not, and this is a colon. That colon is not an equal sign. You put an equal sign, you lose points. It's H naught and then a colon. Okay. And what that stands for is what we say the null hypothesis. So it's the null hypothesis. And the null hypothesis is not what you're trying to show. It's actually the other side. You think of this as a debate. You're trying to show something, and then the other side's trying to show H naught. You're trying to show the majority. Majority want their own Halloween night. The other side says, "Hey, it's not the majority. What's the biggest percent that isn't the majority?" Hopefully, y'all know this. It's just English. What's the biggest percent that isn't the majority? You all know? I don't see y'all typing it in. It's very important. Not a trick question. Okay, let me tell you. No, 50%. Okay? The biggest percent that's not the majority is 50% because the definition of majority means more than 50%. Okay? So since 50% is not the majority and that's the biggest possible, what we're going to say is H naught colon, and then we're going to say P equals 0.5. P, because this is the survey question is, do you want, maybe you can pop it in the chat box. Do you want your own Halloween night? Okay. And the only choices are yes and no, and that means we're talking about proportions, and that's P is the letter we use for proportion. And then equals 0.5. So it's very important to understand how this is written. Okay? And then comma, and then the alternative hypothesis. That was the null hypothesis. The null hypothesis is H naught colon P equals 0.5. The alternative hypothesis, we're going to use H sub 1. There's actually two things that you'll see sometimes. I like H1 because that's what comes after 0, but sometimes you'll see people write HA. Okay? But H1 is what we're going to use in our class. And then colon, not equal sign, colon. And the majority means you're more than 50%. So P, the proportion, is greater than 0.5. And that's called the alternative hypothesis. The alternative hypothesis is what you're trying to show is true. The null hypothesis, that's the other side. Any questions? Any questions on the first step? The first step is to write down the null hypothesis and the alternative hypothesis. And by the way, every week we're going to have different hypotheses. This week we're having this style, and it's going to change a little bit, but this week that's what they look like. Okay, any questions so far? Okay, the next step after you state the null hypothesis and the alternative hypothesis is you want to state what's called the ramifications of a type 1 and a type 2 error. Okay? So what are the ramifications of a type 1 and type 2 error? So first thing is to understand what these mean. The type 1 error means we're going to reject the null hypothesis, but we were wrong. Remember, error means you made a mistake. You got something wrong. So reject the null hypothesis, but the null hypothesis was true. Okay? Rejecting the null hypothesis means accepting the alternative hypothesis. So what you're trying to show is true. You say, yes, I got it. It's true. But you were wrong. That's a type 1 error because it wasn't really true. You just had information to show it was true even though it wasn't. Any questions on that? All right, so let's think about what are the ramifications of a type 1 error. Okay, first thing, I don't know if you know what the word this is English, not math. What does the word ramification mean? Maybe you can type in the chat box. What does the word ramification mean? Again, this is not a math question, it's an English question. So if you know English, yeah, it's a consequence. I like to think about it as the bad things that happen. Okay, these are the bad consequences. Okay, are the ramifications. So we got to say, what are the bad things that are going to happen if you end up rejecting the null hypothesis, but the null hypothesis was true? So that means we're going to say that P is greater than 0.5. We're going to say the majority. We're going to say the majority of adults, right? Or we're going to publish it if we're, the news group. We're going to publish that the majority of the adults want their own Halloween night. But on the other hand, we don't have a majority wanting the whole Halloween night. Any thoughts of some consequences, some ramifications that occur? I don't see y'all jumping in. So let me give you an idea. Hey, if we publish that the majority of adults want their own Halloween night, then a lot of adults are going to say, "Yeah, I'm going to go off and do my fun stuff. Screw the kids. I'm not going to be home to give out candy." Does that make sense? So the ramifications are they're going to publish an article, and the adults are tricked into thinking it's normal to want their own Halloween night. And maybe they're going to go to an adult party instead of giving candy to trick-or-treat children, and the children are going to miss out. Do you see that's pretty bad? Okay, and maybe people are going to be upset at this adult because they weren't there to give out candy. Do you see? Okay, that's a type 1 error. Type 2 error is there's not enough evidence to reject the null hypothesis. We also call that fail to reject the null hypothesis. But the null hypothesis wasn't true. The alternative hypothesis was true. Okay. I do want to note is that when you're doing statistics, you can end up with saying, yeah, I was right. H1 is true because I rejected H naught. What you never do is say H naught is true. All you say is, I don't have enough evidence to say H naught is false, which is not the same thing as saying H naught is true. Okay. But the ramifications, now think about it. Now you weren't able to publish and tell everybody, hey, most adults really want their own Halloween night. Okay. You weren't able to say that. And that's really what it was. So you can have a lot of adults that won't go to a party because they feel like they're going to be, looked at badly. And they're not going to have fun at a Halloween night. Does that make sense? So it's normal for adults to want their own Halloween night, but there's no article on this, and they do not have fun at a party when that should be fine. Because a lot of people can go to the party, but didn't go because they read this article. Any questions on this? Okay, so the next step is you decide on what the level of significance should be. So let me explain what that means. So the level of significance is the probability of a type 1 error. Okay, the standard level of significance is 5%. That's very important to know. Okay, we're always in our class, we will always use either 1%, 5%, or 10%. So 0.01, 0.05, or 0.1. Okay, if a type 1 error is really, really bad, then you want this to be a very small chance, which means you're going to be using 0.01. If a type 2 error is really bad, then you're going to say, it's okay, I don't need to have type 1 error to be, so unlikely, but I want to make sure my type 2 error is unlikely. And the way you do that is you increase the type 1 error, and that actually decreases the type 2 error. The math is too hard to get into the details, but I just want you to know in general that's what that means is increasing a probability of a type 1 error is going to decrease the probability of a type 2 error and vice versa. Okay. So now you say, well, what do you think's worse? Making someone kind of sad because they didn't go to a party, or having a lot of people not being at home and the kids don't get candy when they go trick-or-treating? What do you think is worse? Or do you think they're equal? What do you think? Adults not being able to go to parties or children not being able to have a door open when they go trick-or-treat and get their candy because the adults went to a party? Yeah, I think hurting the children is worse, but sorry if I'm, one to really care a lot about children, but I really think it's important to take care of children. So that means that if it's worse to have sad children, the type 1 error is worse. Do you see? The type 1 error is when you're going to have sad children. when you shouldn't have had. So because type 1 is worse, we're going to make the type 1 error probability be smaller. So we're going to let that probability be 0.01. I do want to let you know, do you know how to read this letter right here that I just highlighted after the word so? It's not bad handwriting, by the way. I typed this. Kind of typed. Here's a hint. It's the first letter of the Greek alphabet. Yeah, alpha. Alpha. It's not A, it's alpha. Okay? It's alpha. When I was a kid, everybody knew alpha. Okay, and the new beta, that was the second letter. And the reason is our big supermarket that everyone had was called Alpha Beta. And now that went bankrupt, I think, or is gone or whatever. But this is alpha, and that's the letter we're always going to use to write down the level of significance. Okay? So the next step is actually the hardest step of all, and that is collect the data. Okay, because then you have to go like they did in terms of this particular study. They went and surveyed 1,000 adults. You know how hard it is to get 1,000 adults to answer your survey question? Okay, so collecting the data is the hardest part in the real world. Now, we're not in the real world, we're in a class, so we just talk about it. But the real world, that is a lot of work to, survey 1,000 people. And 1,000 people is usually what you want to survey for a yes/no question because um, that tends to have a margin of error about 3%, which is what most people want. Okay, so you're going to collect the data. Then you're going to put the data into a computer and you're going to calculate the p-value. Okay, that's the next step. So, what computer do you think we're going to use? And by the way, you are required to use this computer. Okay, if you do it some other way, I'm going to take off points. You have to use this computer. It's free, it's easy to get to. ChatGPT does not use this. In fact, you're going to get slightly different answers because of rounding issues. This actually has really good precision, and you don't have to do any work because I did all the work. But ChatGPT tends to have rounding issues. So use that, it's going to mess you up. So use this computer. What calculator number do you think? Okay, I heard 15. Let's read it. Calculate hypothesis test, that's good. For a mean with statistics. Are we talking about a mean? We're not talking about a mean because this was a yes/no survey question. Means does not yes, no. That would be a number answer. And no one said 17 or 12 or something when I asked you, do you do you want your own Halloween night? Yeah, so this is going to be 17. It's a hypothesis test for a proportion. Okay. And notice, as I mentioned, I made this calculator in the order at which you do things in this class. Turns out 15, 16, 17 is this week. Okay. And they can be done in any order, but because they're all in the same chapter. Okay. So hypothesis test for a proportion. And what it asks you is the following. First, it asks you for n. N, if you look over here, n, hopefully you know from what we've been doing in the past, is a sample size. They surveyed 1,000 adults. So n is 1,000. Then it asks for x. X is just like in the confidence intervals, it's the number of adults who said yes to the survey question. How many adults said yes? Hopefully you can do this without a calculator. I mean, just how many adults said yes. That's actually a pretty easy thing to look at. How many adults said yes? 54%. But how many? Not what percent. How many? There were 1,000 adults. Very simple. So we're not going to put in 54. What are we going to put in? Yeah, 540, because 54% of 1,000 is 540. Just means, move the decimal 3, and you get 540. Then it asks you for what's called P naught. So here's how you find that. See H naught? It's the P for H naught. Do you see how that works? So that's why, and most people call it P naught, but I want trying to make it easy. P naught, it says P equals 0.5. So P naught is 0.5. Any questions on that? Okay, then it asks you, do you want a less than, a greater than, or a not equal to? And that's easy. You just look at your H1 and you'll see that had a greater than, because our alternative hypothesis is P is greater than 0.5. So I need to click on greater than. Any questions on this? And then I hit calculate. And it gives all kinds of things, and I want to talk about these things so you understand. Okay? The first thing it gives is Z. Okay? When you have a proportion and you have a large enough sample, and definitely it's large enough, NP was 540. By the way, if you have a yes/no question, you cannot have a decimal for the NP. Okay? So you should always round to the nearest whole number because that will give you your true NP. Does that make sense? I noticed on some of your last week's stuff, some of you didn't round in the yes/no questions. You can't have fractional answers. So the answer really is 540 for NP. And that is certainly bigger than 5, not bigger than 10. 10 is not an important number. Bigger than 5 in our class is what we used. I was very clear about that 2 weeks ago. But if you didn't hear it, then you lost points. Okay, NQ will be 460 because 1,000 minus 540 is 460. And that is also bigger than 5. Since we have proportions, that's the important thing. And because of that, that means the central limit theorem applies, and we can actually do this. Otherwise, you can't even do it. Okay? The Z is the Z-score for this 54%, right? So again, the mean is 0.5, because in the central limit theorem, the mean is the proportion. And standard deviation is messy, but the Z is a Z-score, and that's about 2.5298, or about 2.5-ish. And that's called the test statistic. So this Z is the test statistic. P, this gets a little confusing because letter P is used for a lot of things. This P is called the p-value. And what it means is the probability that if H naught is true, and we did a study of 1,000 adults. So if it really was 50% of all adults want their own Halloween night, and we did another study of 1,000 adults, then there would be about 0.57% chance, 0.0057 chance that at least 540 of the people surveyed in our new study, not this one, but a different study, would want their own Halloween night. Okay. Then this right here, again, we can use the central limit theorem so we have a normal curve. Okay, so now what I did when I coded all this is I put in different values. If we use alpha as 0.1, that's right here at the edge of the green, the left edge. If we use alpha equals 0.05, that would be the edge of the red. And if we use alpha as 0.01, that would be the edge of the blue. Okay, we're using alpha equals 0.01. So the rejection region is everything to the left, everything to the right of this blue part. All this blue stuff is called the rejection region. Anything bigger than this value right here, this value right here has a z-score, has a proportion of 53.6% about. So this is called a right-tailed test because we have this greater than, and greater than is on the right. Anything far, far to the right for the sample proportion will be enough to say, yep, H1 is correct. I have statistically significant evidence to show that H1 is correct. Now, 54% is to the right of this 53.6%. Any questions on kind of the visualization of what's happening here? So it'd be a very, very small probability that if it really was 0.5, then we would get such an extreme value as what we got, which was 0.54. Anyone lost on what I just said? This is very important. All right, so now let's go put these things in. So the test statistic, I'll just copy and paste. And we have, let's write this down. I don't think I put it there, so I'm gonna put it here. Let me write z equal. Let's make it bigger so you can see it better. And that's called the test statistic. The p-value was, I rounded to 0.006 about. Okay, and I want to give you some vocabulary that you're required to know. If the p-value is less than 1%, 0.01, then we're going to use this word strong. Okay, then you have strong evidence. That means you're really confident that it's really going to happen. Okay, and then you have to have the words statistically significant evidence if the p-value is less than the level of significance. So there is strong statistically significant evidence. So I want to emphasize, let me shout it out loud because you asked us, sometimes you don't hear it. There is strong statistically significant evidence. Okay? Strong because our p-value is less than 0.01. If the p-value is, say, 0.02, then you don't have strong statistically significant evidence no matter what. Okay? And then you would conclude that the population proportion, it's not about the sample. If you don't use the word population, then you're not really saying whether you're talking about the sample or the population. So we need to say the word population. Got it? These words are essential, and you'll lose points if you don't have it. And then don't write mean if it's a proportion. A lot of people make that mistake too. Okay, make sure that you are talking about the right thing. Of American adults who want their own Halloween night is greater than 0.5. Any questions on the conclusion? Just a note, had we gotten, let's say we, did a different study and we got a p-value of, let's say, 0.37. Then it would be real similar, but you wouldn't say there is strong statistically significant evidence. You would say there is statistically insignificant evidence to conclude, and you write everything else the same. You never say that you conclude the population is not greater than 0.5. You only say there's statistically significant evidence, and that means you've got it, or you say there is statistically insignificant evidence. Insignificant evidence either means that it just wasn't true, or it means your sample size was just too small and you weren't able to show it. You just got bad luck. That could happen too. Any questions on this? Okay, let's interpret the p-value. Okay, so it's very important. This is, that basically, I put this out here so you know the wording that you should use. Okay, it won't always be about Halloween, by the way, but you would say if, and very important. This word if has to be the first word. Here is there is has to be the first word. So if the population proportion of all American adults who want their own Halloween night is 0.5, and if another study of 1,000 were surveyed, then there would be a 0.6%, a very tiny percent probability that at least 54% of them would want their own Halloween night. And if there's such a small probability, then you say that it's probably not true. Does that make sense? Any questions on that? Okay, let me give you an example. Oh, let me do one more thing before I get to the example, another example. Okay, let's interpret the level of significance. Okay, and the level of significance, remember, that was the probability of a type 1 error. So if the population proportion of all American adults who want their own Halloween night is 0.5, and if another study of 1,000 were surveyed, okay, notice that interpreting the p-value, then there would be a, and interpreting the level of significance starts exactly the same up to the word a. Okay, so that is important. And the wonderful thing about an online class is everything you do is on the computer, which means you can copy and paste. So once you've got it typed in for the p-value, all you do is copy and paste it for level of significance. And then you say there would be a 1% probability, because remember, our level of significance was 0.01, 1%. So there'd be a 1% probability that we would end up falsely concluding that fewer than 50% of all adult Americans want their own Halloween night. Oh, sorry, more. Whoops, that's my mistake. More than. Okay, because our H1 was at more than 50%. Any questions on interpreting the p-value and interpreting the level of significance? Okay, it's very important to understand the wording because I'm going to ask you these things. Okay, you're going to have to do this week for the discussion assignment. You're going to have to do it next week for the exam. It's an odd week, so there's no exams this week. But you're going to have to, but next week, you're going to have to know to use this wording. And I will ask you, not about Halloween, by the way. Okay, but you have to use this wording. So note the null hypothesis, what you're hoping to refute. And the alternative hypothesis is what you're hoping to find evidence that is true. Let me give you an example that helped me make a lot of money. Okay, that you can't make money this way anymore. But a long time ago, right after I turned 21, any guess on what I did after I turned 21? By the way, it wasn't drink a lot of alcohol. I'm not one of those alcoholics. Any guess what I started doing? And I lived in Southern California, by the way. I mean, stats you can do before you're 21. You can do that when you're 20. Okay, maybe you don't know. I went to Las Vegas and I was a card counter. And one of the things that would happen is they would bring in the casino would bring in a professional magician, basically a cheater, to deal. And what I would do is I would run the hypothesis to see if their cards were random or not. Okay, we'll get into more details as the class goes on. And if the p-value was really small, that means they were cheating. And if they were cheating, you know what I did? Okay, because that means I was able to reject the null hypothesis and say, hey, it's not true that things are just random. I know that there's cheating going on, and they're cheating on me. So what I do? So I rejected the null hypothesis and I left the casino. And then I came back a little later because then there'd be a new dealer that wasn't cheating. Okay. That was the old days. I don't know if they cheat any. I don't think they cheat anymore. Now they hired me to help them make it so that card counters can't win, but that's a whole different story. Okay. So that was a, personal use of hypothesis testing. All right. Let me give you another example. Okay. And I apologize that if some of you aren't in Tahoe. Hopefully, if you're not in Tahoe, I mean, if you at least you've been to Tahoe because it is one of the prettiest places on Earth. It's such a beautiful thing. And one of the things we really care about in Lake Tahoe is what we call lake clarity. We want to make sure that our lake pretty much stays water and not murky and gross. That makes sense? And one of the things that can make a lake have issues is a pH that's not water pH, which is 7.0. So if you haven't had chemistry, you can just trust me on this. You probably heard the word pH. You may not know what it means, but that's okay. So one of the things that we do this every spring, is we measure the pH, okay, and a bunch of other things, but I want to focus on the pH. We measure the pH of the water that flows in via the creeks into Lake Tahoe. And I volunteer, and there's like, I think there were like a couple hundred volunteers. So there's a lot of creeks. And the question is, does the pH differ from 7.0? Because if it's much higher, that's not good. If it's much lower, that's not good. You want it to be just like regular water. Any questions on the idea? All right, so this is going to be a hypothesis test. This is science. Science needs hypothesis testing, by the way, whether it's like, chemistry science or social science too, like psychology or sociology or even medical science like nursing. Okay, you definitely do hypothesis tests to find out if what your idea is right or not. So here's what we've got. We have a null hypothesis and alternative hypothesis. Okay, here you measure the pH, and I don't know if any of you ever measured pH, but you look at the reading of the pH, and the pH meter does not say yes or no. It gives you a number, like 5.8, okay, or 7.3. It's not a yes or no. When you measure the pH, it's a number. So because of that, it's not a proportion that we're looking at, it's a mean. So we're going to have H naught colon, and now instead of P, we're going to have mu. You're used to this mu. And then it's going to be equal. There's always an equal with H naught, 7.0, because we want to see, hey, is there a problem with the water? That's what we're trying to show, that there is a problem. And if there isn't, then we don't have to worry about it. So if there isn't, that's mu equals 7.0. H1, the alternative hypothesis, colon, is mu is not equal to 7.0 because again, high pH is what's called basic. Low pH is what's called acidic. You might have heard those words. You don't need to know that for stats, but if you ever do chemistry, you got to know about that stuff. And if it's either basic or acidic, that's bad. Okay, that means some of the life can't live in it. It means that it's just other life gets murky. It's just all kinds of problems. Okay, notice that we have this not equal sign. If you don't want to type the not equal sign, I will let you write for your exams or for your discussion. You can write NOT and then the equal sign. Okay, and that is very easy to find on the keyboard. So you're welcome to do that. For your project, I want you to do symbols because that you can get help with, and I'll show you how to do that. But you're welcome to do not equal to. Okay? Any questions on H naught and H1? Okay, so notice this is going to be what's called a two-tailed test because If it has a very high pH, we say, hey, the pH isn't 7. If it has a very low pH, you say, hey, the pH isn't 7. So high side and low side will make H1 true. Do you see that? So we call that a two-tailed test. Okay. So the next thing is we look at type 1 and type 2 error. It's the same, step-by-step process that we did before, but now we're talking about means. That's the only difference, and we have a not equal to sign. So if we have a type 1 error, that means, hey, we're able to show H1. We said H1 is true, but it wasn't. So we have statistically significant evidence to show the pH differs from 7, but it is 7. Okay, so we ended up saying we got our evidence to show that there's a problem with our lake. Okay, so the government's going to fund a very expensive project to mitigate the pH issue in the creeks. Okay, but it doesn't need to be done because there's no problem. And the government wasted a lot of money. Okay, by the way, anyone know how much money the government has spent on helping our Lake Clarity and Lake Tahoe? You're in Lake Tahoe, you might know. If you're not, you probably have no idea. Any ideas? I don't see y'all jumping in with numbers. Okay, over $100 million. Okay, so that'd be a big waste of money if there wasn't any problem and they put all this money into it. Do you see how terrible that would be? That would be a bad error. But now let's look at the type 2 error. Type 2 error means that you don't have evidence, right? You fail to reject the null hypothesis, so we don't have evidence to support the claim that the pH differs from 7. But it does. So that means that there are issues with the water flowing into Lake Tahoe, but we weren't able to detect the issues. And what's going to happen is that there's not going to be any funding given because they're going to say, hey, we don't have any evidence to show there's issues, but there were terrible issues. And Lake Tahoe plants and animals are going to go extinct. We're going to lose Lake Clarity. It's going to be an environmental disaster. Okay? Now, what do you think is worse? Wasting money or an environmental disaster? Okay, and by the way, in this class, as long as you have good reasoning, I'm okay with it. But what do you think would be worse? Wasting a whole lot of money or having an environmental disaster? What do y'all think is worse? Kind of like climate change stuff. Costs a lot of money to deal with the climate change thing. And if H naught turned out to be true and there wasn't a problem, if we had a type 2 error, then we've wasted all this money and we could have just used oil. Okay. On the other hand, if you don't waste the money, then guess what? You have disastrous climate change and the whole world falls apart. Okay. So I apologize if you don't agree with me, but I'm an environmentalist and I think it's a lot worse to destroy the environment than to waste some money. But that's up to you. As long as you have write a sentence or two of why, and that's okay. But you have to explain why. So I think the type 2 error is worse. So with the type 2 error being worse, that means we're going to use a 10% level of significance because that means that we're going to let the type 1 error have a bigger chance, so the type 2 error has a smaller chance. And remember, the level of significance is the probability of a type 1 error. So we're going to use the bigger number. Okay. So just to let you know, I did this work and I got X bar was, I mean, I as in we, I should say, like there were like over 100 volunteers. And we got a 6.4 for X bar. The standard deviation was 3.5, and we looked at 15 creeks. Okay. All right. So by the way, notice that 15 is less than 31. And we've been doing this a couple weeks now. If 15 is less than 31, we must assume the distribution of pH level is normal because we have a small sample size. Okay, so now let's go to the calculator. Can I use this calculator? What do you think? Can I use the calculator I just used? Yes or no? Should be easy to type in the chat box. Can I use this calculator? Yes or no? See what you think? Because it's very important you're using the right calculator. Okay, I see in the chat box, no, we can't because this is for proportions and we have means. We're talking pH, it's a number. What was the pH? Maybe 6.8. We don't say yes or no. So I can go back to the calculator menu. What calculator should I use? Based on the problem that I just showed you. What should we use? Yeah, 15. Hypothesis test for a mean with statistics. We don't have data here, we have statistics. We were given the X bar and we're given the standard deviation. Okay, sigma will almost be always unknown, but some other professor from a different college asked me to give you choices, but you almost never know the population standard deviation. So usually you leave that. S, that was the standard deviation of the sample, and that was 3.5. X bar. X bar was the 6 because that was the 6.4 because that was the mean pH 6.4. And then N was 15. We sampled 15 creeks. Mu naught, remember that? Mu naught comes from the H naught. And the H naught was mu equals 7.0. So mu naught is 7.0. Any questions on this? Then we have to choose less than, greater than, or not equal to. Well, in our H1, we had a not equal to. So that should be not equal to. And you calculate. And notice now we have a two-tailed test because not equal to means far left, far right. Both of them are means H1. We're going to say H1 has statistically significant evidence for H1. Okay. So that's why there's two sides. Our test statistic is no longer Z. It's not a normal distribution because we don't know the population standard deviation. So we use the T, if you remember students' T distribution. And our test statistic is about negative 0.6639 or so. And our p-value was this 0.5175. Okay. Notice 6.4 is like right here. And if you look at it, the rejection region is over here, 0.1, that's in green, that's here and here. And you have to be far from 7. And 6.4 is not far from 7 compared to the rejection region. Do you see how that works? It's close to 7. So that means if it's close to 7, then it's not that different from 7. Maybe the pH really is 7. Do you see? Remember, if you have a sample, you're not going to get exactly the mean, the population mean. So our p-value is 0.5175. Okay. So that's about, by the way, 0.5175 is about 0.52 if you want to go 2 decimals. 0.52 is a lot bigger than zero point 0.1. So there is statistically insignificant evidence. Notice the big difference is IN. You get that wrong, you've totally screwed up. Means you made the exact wrong mistake. Exact opposite of what you were supposed to do. Does that make sense? So that'd be the worst mistake to make would be to not have that IN. There is statistically insignificant evidence to support the claim that the population mean pH of water that flows into Tahoe differs from 7. Any questions on that? Okay, so pH may not be a problem. Okay, now what does it mean to have a p-value of 0.5175? We can say if the population mean pH in all creeks that flow into Lake Tahoe is 7, and if we measured another 15 creeks, then there would be a 52% chance that that sample mean for the new study would either be less than 6.4 or greater than 7.6. Okay, 6.4, that was our sample mean. Okay, that was up here. Where were we? Right here. X bar was 6.4. How did I get 7.6? Any thoughts? How did I come up with 7.6? Very basic math, but you gotta have a little bit of math. Maybe sixth grade. Any thoughts on how I got 7.6? Okay, the idea is 6.4. That was zero point 0.6 less than 7. That's how far away on the left we were from 7. We were zero point 0.6 away from 7. So if we're zero point 0.6 on the left, then the right would be 7.6 because 7 plus zero point 0.6 is 7.6. 7 minus zero point 0.6 was 6.4. Any questions on how I came up with the 7.6? This is often a very hard part for people because there's a little bit of math, not anything heavy. All I did is subtract and then add. 7.0 minus 6.4 is 0.6. And then I said 7 plus 0.6 is 7.6. Any questions? Okay, to interpret the level of significance, notice that all the way up to there would be a is the same. So if the population pH in all creeks that flow into Lake Tahoe is 7.0, and if we measured another 15 creeks, then there would be a. Now our level of significance now we chose as 10%, or 0.1. So there'd be a 10% chance that we would end up falsely concluding that the population mean pH of creeks that flow into Lake Tahoe differs from 7.0. Any questions on this? Any questions? Okay, so just let you know, most important thing that strongly recommend is practice. Okay, you got to do a lot of practice or you're not going to be able to write this stuff out. And you need to be able to write this stuff out. So the discussion post assignment is going to make you practice. The homework is going to make you practice, but I shouldn't say homework because everything is homework for an online class, but because you do everything at home. But the chapter assignments, I guess I should say. But with the chapter assignments, since they're computer graded, that means that they're going to be multiple choice and you get to pick the right wording, but not type it yourself. So what I recommend is when you're doing the practice assignments, the chapter assignments, write it out first before you look at the multiple choice, and then see which one is the one you wrote. Okay, are you ready for another example? Okay, suppose you want to see if women are not drinking the recommended 2.7 liters per day on average. Not sure if you know, but I looked it up, and it is recommended that women should be drinking 2.7 liters of like water, not alcohol, by the way. Like water, I mean, it could be orange juice too, but but hydration stuff. Okay, so notice this is also about a mean because it's the mean amount of liters a day that women drink. H naught, that's the null hypothesis, colon, is mu, because now you're going to ask, how much water are you drinking each day? And you might say, I'm drinking 3.1 liters. And that's a number, not a yes, no. So mu is equal to 2.7. H1, we want to see if women are not drinking the recommended. Okay. And remember, that means they're drinking less if things are a problem. So mu is less than 2.7. Does that make sense? All right. Let's suppose we decided on a zero point zero 0.01 level of significance. Okay, we only have so much time, so I'm not going to get into all the details, but you can look at type 1 error, type 2 error, see which is worse, and we're going to decide type 1 is worse because of health issues, and then we're going to use zero point zero 0.01. And then let's say we conducted the study, and this is what we got. Okay, we got these were the answers. So now we want to find the test statistic and p-value. Can we use this calculator? What do you think? Is this a calculator that's usable for what we're doing? See y'all jumping in? Yeah, the answer is no, because this is with statistics, and we don't have statistics right away. We have data. Do you see that? We have the data. So instead, I'm going to go back to the calculator menu. And what calculator should I use? Yeah, this is 16. Hypothesis test for a mean, because we're talking about mu, and we have data. So now we just put the data in. I copied it, and now I'm going to paste it in. Any questions so far? Okay. We don't know sigma. Okay. So notice it says um, type in the values of the data set separated by commons, then type in the population standard deviation sigma if it's known, or leave it blank if it's not, and we don't know the population standard deviation. So just leave that blank. And then our H1 was mu is less than 2.7. So we click on less than. Our mu naught was 2.7. Any questions on that? And hit calculate. Okay, and there we go. Okay, and it gives you some other information because you might need it for other things, and that is the sample mean was 2.54. The sample standard deviation was about 4.888. T is our test statistic because we have a mean and we don't know the standard deviation, so that's why we use the student's t distribution, about negative 1.936. And our p-value is about 0.03. Here's the picture. Notice that we're using a 1% level of significance. That's in this blue here, and we're not in the blue. Do you see that? So let's write down 1.936 or so for the test statistic. P-values of 0.03. here's the conclusion. Notice the p-value, 0.03, is greater than the level of significance 0.01. And if the p-value is greater than the level of significance, that means it's not that unlikely. So we're not going to be able to say, hey, H1 was true. You can't say that. You can't say H0 is true either. All you can say is there's statistically insignificant evidence to conclude that the population mean, okay, these words are really important. Then you need to talk about what you're talking about. Amount of liters that women drink per day is less than 2.7. Any questions at all on this conclusion with this example? Okay. So just a note, here's a template. There is statistically either insignificant or significant evidence to support the claim the population will either be mean or proportion. And then you got to talk about what you were talking about. Whether it's amount of, liters that women drink, or might be the turbidity, it might be the pH of the water. Okay, it could be the percentage of people or the proportion of adult Americans who want to, go on their own for Halloween. So all kinds of different things that you could be interested in. So that's why when I write X, 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 that means you need to talk about the question and it needs to be relevant to the topic instead of general. Okay, if you just go general, then you're going to lose points. And I always let you know where I take off points. What I don't want to do is take off points. I hope you all just get it. Okay. And for the p-value interpretation template, if, and then whatever it means to say the null hypothesis is true, that should be in words in context of the survey. And another sample of however many you asked was taken. Then there would be whatever that probability was for the p-value, and then it's the results of the new study would be at least as extreme as the results of this study, but don't write this. Okay? Write what this means in terms of the study. Whether it's about women drinking or or whether it's about pH of water or Halloween or whatever it might be. Any questions on the template? Okay, for the level of significance template, so it's going to start exactly the same. The null hypothesis is true, but again, if it's in parentheses, that means you need to write it in context of the question. And if another sample of however many we took was taken, then there would be and this would be the level of significance probability, like a 5%. Okay. By the way, social science always uses 0.05. So if you're ever looking at psychology or sociology, everyone uses 0.05. Okay, but regular science sometimes uses, higher or lower. Business or economics uses higher or lower. So there's a lot of things that do use higher or lower. So there would be a whatever probability that the new study result in falsely concluding that. And then I'm writing the alternative hypothesis is true, but you need to write that in terms of the context. Okay, any questions? Any questions on hypothesis testing? There's a lot involved. Okay, this is a very deep week, but there's no project to work on. There's no exam. So spend your time understanding the hypothesis testing because the rest of the whole course is going to need it. Okay, that's just a note. Every chapter from now on is about hypothesis testing. Okay, and other details, but it's going to be at least a main part of it. Sometimes the main part, most of the chapters. Okay, now let's do one more example. This is one I looked up today. I love it because I can always find stuff. Okay. Do fewer than 50% of all adult Americans approve of the job Trump has done so far? Okay. So again, you need to, do research to find out. And Gallup This I found under Gallup poll. Gallup found that 41% of their 1,006 surveyed approve of the job Trump has done so far. Okay. They had 412 say, yes, I approve. And the other 590, what is it? So 594 did not approve. Okay. Notice those are both bigger than 5, so that means the central limit theorem works, and we can actually do this. Okay. So then you're going to write H naught. Notice the question is, do you approve of the job Trump has done so far? Let's see if you can pop in the chat box your answer to that. Do you approve of the job that Trump has done so far? Okay. Notice nobody said 4.3 or 72. Okay. Your choice is either no or yes. Does that make sense? So that means we're talking about proportions. So H naught colon is P for proportion equals 0.5. Because the question is, do fewer than 50%? So the other side, no, it is 50%. H1 colon P, and now it's going to be less than because fewer is less than 0.5. Okay. Just for time reasons, I'm going to tell you I went to the calculator and I found the test statistic was negative 5.7382. And the p-value is 0.000000004786 about. I do want to give you a heads up in the calculator. It said 4.7586 and a bunch of others. And then at the very end, it had E negative 8. Oh, sorry, E negative 9. And that meant that you got to move the decimal place 9 places. Okay, so always pay attention. If you ever write down that the p-value being a number that's bigger than 1, you screwed up. That can never happen because p is a probability of something happening, which can never be over 1. So very important. Okay. Clearly the p-value, by the way, this is definitely social science kind of stuff. So we're going to use 5% level significance. And the p-value is clearly less than 0.05. And not only is it less than, it's very much less than. And when it's very much less than, you can use the word strong. Okay. If it was, say, 0.04, you would say there is statistically significant evidence, but you wouldn't say strong. So strong means less than 0.01. So there is strong statistically significant evidence to support the claim that fewer than 50% of all adult Americans approve of the job Trump has done so far. Any questions? Any questions on this example? I do want to let you know that interpreting or talking about the conclusion, this is the conclusion, is much more important than interpreting the p-value and the level of significance. So anytime you have a hypothesis test, I'll always ask you to interpret the conclusion. And occasionally I'll ask you about the p-value and the level of significance interpretation. Okay, but if I ask you to interpret the conclusion or write down the conclusion, don't interpret the p-value level of significance. Just do this part. Okay, if you don't want to lose points. Any questions? Okay, so here's another example. Again, I like to give you lots of examples. Okay, do more than 2/3 of all Americans support the US in taking steps to reduce climate change? Okay, let's run the full hypothesis test. Okay. By the way, if I asked this when I first taught this, it's not even thinking about more than 2/3%. Not even close to half. But that was like so many decades ago. Things have changed. It's one of the things, living a longer life is that you really watch things change. And now we're really noticing climate change. But when I first taught this class, so we're talking about the early 90s, things were different. Okay. Let's say H naught. We would say H naught, P equals, I wrote this as a decimal, so I took 4 decimal places, 0.667 is 2/3. And H1 would be P is greater than 0.667. Notice the proportion, either yes or no, you support the US taking steps. Okay. And again, you can do this. Oh, I didn't write down the p-value. 2230.7. So here, we're going to have to go back to the calculator. We're going to have to go to the hypothesis test for a proportion. Our n again was, where was it? 2230. Our x, they said that p hat was 0.7. So what we can do is we use a scientific calculator and you go 0.7 times 2230. And that's 1561. P naught was 2/3, which was point, bunch of sixes and then a 7. Our inequality is greater than, and we calculate. So what do you think? Is there evidence or not? Is there statistically insignificant evidence or significant evidence? This calculator shows it all, but only if you know what you're looking for. What do you think? Put it in the chat box. Is it statistically significant or statistically insignificant? Not seeing y'all jump in. Should be obvious. From the p-value, from the picture. Okay, p-value is 0.00042. That's a tiny number. It's less than any level of significance you'd ever think about. So this is statistically significant. You can also see that 0.7 is in the rejection region. So we can say there is strong statistically significant evidence to conclude that the population proportion, okay, those words are important, population proportion of all Americans who support the US in taking steps to try to reduce climate change is greater than 2/3 or 0.6667. Any questions? Any questions on this example? Okay, I think I'm gonna jump out of this and go to here. The secret word is there. There, by the way. Very important to know how you spell the word there, because there is statistically significant evidence. It's the first word you have to have when you're stating a conclusion is there. Just like the first word when you are interpreting the confidence interval was with. Okay, if you don't have that first word, I take off points, by the way. So I try to make it obvious. So I know someone asked, how do I know? Well, I'm telling you. There is statistically either significant evidence or insignificant evidence. So there. Okay, so let me talk a little about project two. So the first thing, and this is something that you should all make sure that you already have done. If not, then you should be stressed out and you should make it happen. What's the first thing? Same thing, same first thing that you did for project one. Yeah, make sure you have groups. And again, you are welcome to use the same groups if you have more than one person in your group. Okay, but not required. If you had two people, ask for a third person. Okay. If you hated the other person, then ask to join a different group. So, that's up to you, but, hopefully you can get along with people and you can work together. So that's going to be really important. Okay, so project two. Project two is actually going to be about next week, but this week and last week were the 2 weeks to get ready for next week. So what did we do last week? In 2 words, last week was all about what? 2 words. Put in the chat box. Yeah, confidence intervals. Okay. And what is this week all about? 2 words? Different words. Different than different than last week. Yeah, hypothesis tests. Okay. So the project two will be all about confidence intervals and hypothesis testing. Okay. You're not ready for it because next week we're going to do the most important type of both of those, and that is comparison studies. Okay. So that comes up a lot more in the real world than what we're doing. So what we did last week and what we did this week was to really get you ready for next week. Okay. Because it helps to have what we did last week and this week to really try to start understanding confidence intervals and hypothesis testing. And then we'll do both with comparison studies. So I do want to let you know that's still going to happen. So you're not ready quite to do it yet, but I will tell you those are the two. That's what your project is going to be all about. I'd say maybe 90% of your writing will be that. Okay. Or should be that at least. I can't say will be because I don't know what you're going to write, but you should write most of it. Okay. Should be about the confidence interval hypothesis testing. Okay. Um, we're going to be doing for a difference between two means, and that we haven't really talked about yet. That's next week. But I do want to, get you to start, at least get a heads up of what's going on. So again, today is not the day to really talk all about the details. That's going to be next week. The project, by the way, is due. If you go to the syllabus on December 7th. Okay. So you're going to have a lot of time, but again, you want to, next week is when you start thinking about it. But I do want to let you know it's not due for a while, but that does not mean you should wait till the last minute. Okay. In fact, I recommend having it mostly done by the end of November. That way I can give you feedback and you can do a lot better. Those who got feedback did a lot better than those who didn't. Okay. So, because it makes all the difference. So again, if you wait till the last minute, it'll be awful for you. Okay, so that's kind of the main thing that I wanted to just kind of mention for the project. I'm giving you more of a heads up, no details yet. So you're not ready to, do a full investigation, but you're definitely ready to get partners. Okay, three is better than two. Two's allowed. We have a little time. So let's how about this one? Do the majority of people want to eat instead of drive while in a car? Okay, this is something that I thought was going to happen a long time. I mean, already, and it didn't. But I thought by now we wouldn't be driving because hey, if you're alone in a car and you're hungry, can you just like spend all your effort and all your concentration focusing on your dinner? Is that safe? What do you think? Okay, I'm looking at your answers, and clearly none of you are living in San Francisco. Why might it be safe in San Francisco? Okay, I've actually seen this. They have because full self-driving cars. Yeah, Waymo. You don't need a person to drive. Okay, I thought by now we'd all be doing it, but it's not quite there yet. But I thought it would be. By the way, statistically, it's a lot safer than human driving. Okay, I've looked at the data, and it's actually much safer in terms of the accidents per mile and deaths per mile. There's a lot less with self-driving. Okay, so one of the things is you might want to ask, hey, do you want to eat? Maybe you want to, look on your phone because that's something you should never do when you're driving, but you could be, if you're in a self-driving car, it's fine. Okay. So here, majority is P equals 0.5. P is greater than 0.5. Okay. And P hat was 0.51. Okay. P hat was the sample proportion. N was 4,700. And we can just pop it in. 4,700 was N. We had X. We need our calculator. 4,700. Need to go there. 4,700 times 0.51. And I get 2397. Yes. Our P naught is 0.5 now. And again, we wanted to find out majority, which means more than half. So greater than. And you calculate. P now is 0.085 or maybe 0.09. So now we're looking at 0.09, and that, if we were going to use 0.05 as our level of significance, that would be higher. And you would say there is statistically insignificant evidence to support the claim that the majority or more than 50% of all adult Americans, and then if you read this, want to eat instead of drive while in a car. Okay, it doesn't mean that we don't have a majority. It means that we don't know if we have a majority. Do you see the difference? Any questions on that? Any questions? Thought I'd give you, another example. There are so many important examples. Almost just to let you know, medicine. Medicine can never be improved without a hypothesis test. Okay, that is an absolute, because I know some of you are going to go into medicine and you can never approve it. It's against the law to approve it without a hypothesis test done. It has to be done. Okay. And that includes not just, giving fluid or medicine, but also doing medical techniques and making it happen. You have to have samples, you have to have hypothesis testing. Okay. And it's really important. Any questions? Okay, now it's around 7:30, 7:29, close enough. I always like to try and end around 7:30. And today there was a lot of stuff to talk about, so I wanted to get to the end. Now it's 7:30. So I'm going to stop the recording. Thanks for listening. And I'm always happy to answer questions if you have them, and that could be in student hours too. Make sure, by the way, if you ever pop in a student hour, put on your mic and say something so I look, because I don't just stare at a blank screen for an hour. I'd be bored out of my mind. So make sure you say something so I hear you. So I'm going to stop the recording.